Hello, and welcome to the Utility Bill Impact Dashboard. This tool was created to help stakeholders understand how different residential technologies can influence energy bills. We have used data from the National Renewable Energy Lab, including the effects of the Inflation Reduction Act, as well as detailed building characteristics. This tool is able to project potential bill changes across various climate zones and state-specific conditions. Whether you're a homeowner, policymaker, or other stakeholder, this dashboard will equip you with the insights needed to assess the financial impacts of energy efficiency and electrification technologies. To get started here, this is our homepage. The first page that I would take a look at is this impact summary. So this page is going to be an overall look at what an upgrade may have to the site energy change, operational emissions change, utility bill change, as well as change to the consumer's electricity rate, natural gas, fuel oil, or propane. Then we also have this applicable units. So in this case, we're looking at all states across the United States. So there, as you filter down, this is going to be able to tell you how many units you're looking at in terms of the total number of units across that state. For example, here, if I was going to select Michigan, this number is going to change. It's going to say 3.57 million applicable units. And as I get more into the filters on the right-hand side, this number will change. For example, just how to filter down here, we have several filters for you to choose from. Upgrade names, so these cover a variety of different home technology upgrades. We also talk about area median income, heating fuel, cooling type, vintage, housing tenure, the building type, the building floor area, the climate zone, if you want to look at a specific climate zone within a state or across the country, and then the federal poverty level. Federal poverty level is used in some programs such as the Weatherization Assistance Program, and that's why we've included that as well as the area median income. So for example, if I was going to look at what a minimum efficiency heat pump will do with an electric backup system across all homes in the state of Michigan, you're going to see here that all homes are going to see a decrease in energy change by 5% or greater. The emissions are also going to go down by 5% or greater. However, the utility bill is going to change. For this example, 52% of units are going to see an increase of 5% or greater. If you look down here at the assumed retail electricity rate and fuel prices, that is because Michigan has a higher electricity rate in terms of compared to the US average. So homes are going to be using more electricity and less natural gas, where natural gas is cheaper in Michigan compared to the other states across the United States. Next page that we have created here is our energy burden page. This will look on the same filters, but it's going to look at the energy burden change before and after a specific upgrade. So in this case, again, we're still looking at that high efficiency heat pump with an electric backup. And then the average energy burden here is on the left. Energy burden is the percentage of gross household income spent on housing energy costs. High energy burden is considered 6% or greater. The income and area median income is based off 2019 data. Again, so you're looking at the 0 to 30% area median income. The energy burden before the upgrade is 29. After, it's gone up slightly, and there's an increase in average energy burden for this income level and across the state of Michigan. Down here on this table, we've included a couple statistics to help you look further into the detail. The first one being units applicable to, so this will give you an idea of how many units across the state or your filters are using or are going to fall within this income bin. The baseline energy bill across the year, and then the bill change. So in this case, you're going to see an average bill change of $55. So you're going to see an increase in that bill. And then the average income of that bin as well. So you get an understanding of where those bins are located. The next page here is our payback summary. So again, we've created a couple pages that will look at this. This first one is going to be without any rebates. And so these are looking at every upgrade here on the left. And then this first sort of section is the units applicable to. So basic enclosure, you have 3.6 million units that are going to receive this upgrade across the state of Michigan. The second column here is going to be our payback period. So the red is a negative payback. Gray is a 25 plus year payback. Yellow is a 10 to 25 year payback. The light green is 5 to 10 year payback, and the dark green is less than a 5-year payback. This is going to give you an understanding of how long it's going to take to recuperate the money from the decrease in energy bills compared to the cost to upgrade. We've also included the average upgrade cost to income ratio. So in this case, if you're doing a basic enclosure, the average upgrade cost to income ratio is going to be 0.1 or 10% of the income. And then if you look down here at a whole home high efficiency electrification with an enhanced enclosure, that's going to be 111% of the income. You can also, again, filter down. So if we wanted to look at just 0 to 80% of the area media income, these numbers will change and provide different values. We have looked at it with here rebates. And so if you click on the here rebates, it will show you the same data, but with these rebates included. As you can see, much more favorable paybacks, as well as a lower upgrade cost to income ratio. We've also done the same thing with the home rebates that were put through with the Inflation Reduction Act. Our last page here is going to be our utility bill changes. So this similar is going to show you the basic upgrade, all the upgrades, and then the average utility bill change. So in this case, we have also included this new filter here, the energy savings percentage. So if you wanted to look at homes that are going to save more than 20% in their energy savings, you're going to see that 3.7 million homes are going to save more than 20% of their home energy based off the high efficiency home electrification. And you can see they're also going to save about $62 on average to their utility bill change. Again, you can filter down more to further identify what those homes or buildings are. Our last page here includes some of our information about where we got our data, as well as a description of all the upgrade measure packages that are included throughout the dashboard. Thank you very much for coming, and we look forward to you using this dashboard.